Yes. So we've started the recording. Yes. Hi, everybody. Hi, we are live and in stereo. Let me just take one picture with the peeps. Yes. For Sarabas. Hi. Hi. Okay, great. Now, okay. Chill. Okay. Now, today, what we're going to do is we're going to look into the planning experiments, and the planning experiments are the simplest experiments from for the entire ATP paper. This experiment is the easiest experiment. Normally, it's question number 4, and it's very easy. It's very simple, and I prove why it's so easy and it's so simple because the all the information is given in the question, right? So there are multiple types of planning experiments that may be tested. I've uploaded a couple of videos onto YouTube. If you haven't seen my YouTube channel, it's at Carboxylchem. So it's Carboxyl. You could check it out and it'll help you. I don't get any money from YouTube or whatnot, but it'll help you all, right? Now, other than that, normally it's question number 4. And we're going to start demolishing the questions. Remember, in the planning question, in question number 4, the planning question, right? The most important aspect of this question is to be able to devise a thought process, is to be able to read the question carefully in such a manner that you have an overall idea of what you're going to do in the experiment. Don't just go on randomly writing apparatus and writing, I'll do that. First of all, think what is the possible course of action. And once you have, and it's pretty logical, it's pretty simple, and I prove it to you. And through the words of these questions, you will understand how easy it is to actually do these questions, right? So we'll start off with the first question, toothbright, without wasting any time. And it mostly the questions that I've added, it covers a vast majority of question number 4s. The class is probably till 9:30, man. It's up there in the it was in the poster. Okay, let's start. So it says toothbright is a toothpaste, contains 3 compounds. Okay, it contains sodium fluoride, NaF, right here, and it contains calcium carbonate. Calcium carbonate, by the way, is insoluble, right? And it has water in it. Awesome. Water is what? H2O. Now, this calcium carbonate is insoluble in water. Remember, when something is insoluble in water, when you deal with solubilities, and he's told you that it's insoluble in water. Remember, there'll be some point of time, there'll be a point in time, or the idea that you'll be using is the addition of water, right? So I'll try my best to use water to my advantage, right? As is, sodium fluoride is soluble in water, so we'll have to add water somehow and then filter and whatnot, right? That's just plan an investigation to find out the percentage of calcium carbonate present in this toothpaste. Now, the question in itself is giving you the answer. The question is saying calcium carbonate is insoluble in water. So start adding water and now start devising an overall thought process. What I'll do is I'll add water right here. I'll add water to this toothbright toothpaste, and what will happen is that when I add water to it, I'll add a lot of water. I'll in fact add excess water, a lot of water, and I'll start stirring it and heating it and stirring it and heating it until I just see a solid lump remaining, right? And that's obviously gonna be calcium carbonate. So I'll add water and I'll realize that sodium fluoride is soluble. Soluble means it'll become aqueous, right? And then you'll have a lump of calcium carbonate right here because calcium carbonate is insoluble. I'm first of all devising an entire idea. Now, how do you separate a solid? Yes, you can write in points. It is preferred to write in points. How do you separate a solid from an aqueous solution? You literally separate a solid from a liquid or an aqueous solution through filtration. So if I perform filtration, what will happen? The calcium carbonate right here will be obtained as residue, and sodium fluoride is going to be right here as your filtrate. But I'm not interested in sodium fluoride. What am I interested in? I'm interested in calcium carbonate, and realize that there is a possibility that there may be certain traces of sodium fluoride on calcium carbonate. So first of all, before taking out calcium carbonate from this filter funnel right here, I'll pour distilled water through it. To remove any traces of sodium fluoride, obviously. And then you're going to dry it and you're going to get calcium carbonate. But remember, it is a percentage by a percentage. You need to calculate the percentage of calcium carbonate present, which means you need the mass. In order to calculate percentage, what do we need? We need the mass. So initially, this is the entire thought process. But initially, before you do anything, you'll have to first of all figure out the mass of toothpaste that you take. And how do you figure out the mass of toothpaste that you're going to take? How do you figure out the mass of toothpaste that you take? You're going to use a balance to do so, right? And the examiner wants values. So you're going to say, well, let's suppose take 10 grams of toothpaste and weigh it on, a balance. Weigh 10 grams of toothpaste on a balance. And then initially, once finally, when you have calcium carbonate, you wash it and dry it with a filter paper, you will also weigh this beauty right here. You will weigh calcium carbonate right here on a balance, and you're going to get a reading. Let's suppose it's at 2 grams, or let's suppose not 2 grams, maybe it's at 3 grams or 4 grams, whatever, it does not matter, right? So if it has 3 grams of calcium carbonate, you could figure out the percentage. What is it? How do you calculate percentage? The mass of calcium carbonate divided by the total mass, which was 10 grams, multiplied by 100%. So that's going to give me what? 30%. And remember, you can assume values for yourself, and that's it. Yes. In this toothpaste, how do I know? Because the toothpaste right here. So I'll first of all take the mass of the toothpaste. Now this is the entire thought process. And thank you for the answer, kiddo. Who is this? Dot, thank you. You're a genius. Yes. Okay. Heating and stirring is necessary in order to make sure that the reaction goes a little quicker. We don't have that much time. So remember, whenever you are, you're dealing with something that is insoluble and something that is soluble, whenever you're adding water to it to make the soluble substance become soluble, you heat it, because heating, improves solubility. At high temperatures, soluble substances become more soluble. So you heat it so that all sodium fluoride, it starts to dissolve, because you studied this in your teachers should have taught you that even soluble solids tend to become less soluble at lower temperatures. So you need to make sure that all of sodium fluoride dissolves. And in order for all of sodium fluoride to dissolve, you need to heat and stir it, because even soluble solids tend to become less soluble at lower temperatures, right? Done, done. So now he's saying plan and investigation. First of all, what am I going to do? I will weigh the mass, weigh, let's suppose 10 grams of toothpaste. But how do I weigh 10 grams of toothpaste? Remember, the examiner always says that don't give me apparatus blatantly. If you if you blatantly write the names of the apparatus that are going to be used, you're going to get a 0 mark for it. Why would you get 0 mark for it? Because just writing, multiple apparatus, I'll use this, I'll use this, I'll use it. No, try to integrate it in the answer. So see how I'm beautifully making the answer. I'm saying weigh 10 grams of toothpaste using a balance or electronic balance or whatnot, right? Do you know how much marks this gives me? It actually gives me 2 marks. Literally, it gives me 2 marks. I'm not even joking, 2 marks, right? And then what do I do? Now I know the entire idea behind it, because I'm dealing with solubility. I'll have to add and filter, add a solution, add a solvent and filter, right? So what's the idea behind it? I'm going to add water. And remember, you know that soluble solids tend to become less soluble at lower temperatures. So you add water and you heat it, heat it and stir it as well, and keep on stirring it. Why would you do that? Add water to it. And where do you add water? Add water to the toothpaste. And how do you add it? Add water to the toothpaste, heat it and stir it, obviously in a beaker. So you have to mention the apparatus as you write the answer, right? And you keep on adding water and water. So you'll keep on adding water and stirring and heating and stirring and heating until you just see a lump just left behind. No more solid is dissolving. So until no more solid dissolves, no more solid dissolves. Your toothpaste contains water. Chill out. Yeah? Toothpaste contains water. And then what am I going to do? Yes, it is important to write specific mass. No. Apparatus, you have to write it as an answer. And then, yes, add acid, whatever solvent you're adding, you do this, right? And then you realize that now I know that a chunk of solid is going to be left behind. So what am I going to do? I will filter the mixture to obtain what? To obtain calcium carbonate, yeah, as residue. And remember, this calcium carbonate, it's insoluble in water, so I can further wash it with distilled water to remove any traces of NaF. Wash calcium carbonate with distilled water. You have to write the answer like so. Yes, in bullet points. Yes, in bullet points, please. With distilled water. You don't need to write to remove any traces of NaF, but if you want, you could say to remove traces of NaF. But now it's wet. Now it's wet. What do I need to do? I need to also dry it to get accurate mass. So dry it with a filter paper, or by gently tapping it between two filter papers. Dry it with a filter paper or by gently tapping it between two filter paper and weigh the residue. Now you need to just weigh the residue. For example, I'll say, for example, it's 3 grams. So what am I going to say? What is the percentage of calcium carbonate? The percentage equals the mass of calcium carbonate divided by the total mass into 100%. So that's going to be what? 30%. Yes. And if you want to make a diagram for it, it's pretty simple. You could just make a diagram for filtration right here. And you could even, you can even get marks for drawing the correct diagram. So that's the calcium carbonate, that's the residue, and this is sodium fluoride right here, and this is called a filter funnel, and the inside V, that's basically the filter paper. There's a difference. Filter paper traps the residue. It's good that if you draw it, how long would it take you to draw it? 2 seconds. There's nothing to make a mistake here, huh? It's quite impossible. Pretty easy, huh? It's not necessary, but it's better to draw it. So always understand the idea behind the thought process. Yes, he will accept all of this. Only he will not accept things which are outside the margins. He'll say the barcode. You'll see a barcode. You'll see like two things like this. You must have seen this in the paper, because once the paper is scanned, the only portion that is scanned would be this much. The ones that are inside these circles or whatever, these V shapes. Do we need to write a dot before writing a sentence? Whatever you want, I'm writing it in bullet points because the examiner report says that it's better for students to write it in bullet points. No, question 4 is always still 6 marks nowadays. It can go to 7, 8, probably, I don't know, but it's a set pattern. 2023 onwards, it has just come for 6 marks. Why would it be 10 minus 3? Why would it be? I just want the percentage of calcium carbonate. It could have been 10 minus 7 if you wanted to, get 3. But you got 3 after you weighed it. You got 3 as the mass of calcium carbonate. So mass of calcium carbonate divided by total mass into 100%. Bullet points are allowed everywhere. Done. First experiment done. I told you, this question 4 is the easiest. Yeah. Okay. Then, argentan, I don't know how it's pronounced, but argentan is an alloy containing zinc, nickel, and copper. Okay, zinc, nickel, and copper. Zinc, nickel, and copper both react with dilute hydrochloric acid. Sorry, zinc and nickel both react with dilute hydrochloric acid. Copper does not react with dilute hydrochloric acid. Ting, ting, ting. What would this experiment include? What would this experiment include? This experiment would include what, sir? It would obviously include what? The addition of acid. So somehow I'll be adding acid, right? And I know zinc and nickel reacts and copper does not. Why doesn't copper react with dilute hydrochloric acid? You study this in your acid-base theory. Why? Because copper is below hydrogen in the reactivity series. It can displace the hydrogen in the acid, right? But zinc and nickel, zinc is a metal. When zinc reacts with hydrochloric acid, what are you going to get? You need to know your equations. Yeah. When zinc reacts with hydrochloric acid, what are you going to get? You're going to get zinc chloride. Anything they react, and obviously zinc chloride and nickel chloride, chlorides are soluble, right? So you're soluble except for lead, mercury, and silver. So you're gonna get zinc chloride, and you're also gonna get hydrogen gas right here, because once the zinc displaces the hydrogen in the acid, it forms gas. So remember, a gas is also forming. So these things should come in your brain, right? Now it says plan an investigation to find the percentage by mass of copper in a powdered sample of argentan. Now I need copper. Yeah. So, and again, I'm dealing with mass. If I'm dealing with mass, I need what? I need an electronic balance. I know it's the same question. I know, because I want to develop a pattern in your brain. I've done something very beautiful. You will see it. You will start to develop a pattern. So it's a percentage by mass question. Now, what am I going to do? The overall idea is to add acid here. Okay, what if I add acid here? The examiner has told me that something is soluble in acid, something is not. So if I add acid, everything is going to become soluble and copper lump is going to be left behind. And if copper lump is going to be left behind and everything else is soluble, once you filter it, you're going to get copper as the residue because everything else was soluble. Awesome, 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 awesome. And remember, when will you add, till what point will you add acid? You will add acid until you no more see bubbles forming, right? Because that will be an indication of all the nickel and all the zinc that is going to be used. So until no more bubble, until bubble stops forming, you're going to add acid, 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 acid. So remember, acid should be, in excess. You should keep on adding the acid until you see no more bubbles. And once you add the acid, obviously then you're going to perform filtration. You're going to get copper as the residue because it's not going to react. So it'll just be a solid lump. It's a solid. Alloy is like a solid, zinc solid, nickel solid mixture. It's a mixture of metal with other elements, in this case other metals, right? So you're going to get copper. Beautiful. Yeah. And then how do you know that acid is going to be in excess? You know that you're going to add it until the effervescence stop. This is an experiment. It's not do this, do this, do this, do this. You have to think and visualize, okay, oh my God, I'm performing the experiment. So if I am performing the experiment, I will keep on adding the acid until the bubbles stop forming. If the bubbles stop forming, I'll know that, okay, all the nickel and zinc are used up. They've all reacted. And then what am I going to do? I will basically filter it out. I will get copper solid, and obviously zinc chloride, nickel chloride, and even the acid, because that was in excess, even the acid, zinc chloride, nickel chloride, all of that beauty is going to be is going to be obtained as the filtrate. But I don't care about this. I care about copper. So once you get copper, I know there are going to be what? There are going to be traces. There are going to be traces of zinc chloride or nickel chloride. There are going to be traces of the solution from where you obtained it, right? So you have to pour distilled water through it. You have to wash it with distilled water or pour distilled water through it to remove traces of the impurities, in this case zinc chloride, nickel chloride, or even the acid. Pour distilled water through it. And then you also have to measure it. You also have to measure it at the end, measure the mass, because what do you need? You need mass. So once you measure the mass, before measuring the mass, you also need to do one more thing. What do you need to do? You also need to dry it and then measure it, because think of coming out of a swimming pool. When you think of coming out of a swimming pool, once you come out of a swimming pool, your mass is slightly increased. Why? Because there are water droplets onto you. It may not be in kilograms or grams, but it's slightly increased. So you're going to get an overstated value. So to improve your accuracy, you need to also make sure to dry it. So dry it with a filter paper, and then what am I going to do? I'm going to measure it, right? Because I need mass, I'm going to measure the mass at the end. But also initially when I'm taking the mixture, I'll take maybe like 10 grams of it. And how am I going to do it? I will do it by obviously measuring it with the help of an electronic balance. That's it. That's it, right? Awesome, easy peasy lemon squeezy. So he's saying, what is the apparatus needed? We've already identified it. We're going to integrate it in an answer. Measurements to take, this measurement, whatnot. Procedures to ensure that the percentage is as accurate as possible. You dry this beauty right here. And obviously, when you are adding the acid, you are going to keep on adding the acid until you see no more bubbles to ensure that all the zinc and nickel have been used up. Yeah. And then, how do you determine the percentage by mass? The mass of copper divided by the total mass, which is 10 grams, into 100%. How easy is it? How easy is it? So again, weigh 10 grams of argentan, whatever, nobody cares. Using what? A balance, an electronic balance. Literally gives me 2 marks. I'm not even joking. That's why it's the easiest question. You just need to figure out the thought process, using an electronic balance. Then what do I do? Somebody sings, Shabana is saying, Shabana, it's a very beautiful question. Shabana, Shabana. What was this? My name is Onaija. She is Shabana. So Shabana, you realize that it's already in powdered form. So if it wasn't in powdered form, you would have crushed it. But it's in powdered form. So I don't need to crush it. Shabana was the name of the student who asked the question. And we would crush it using a pestle and a mortar. Yes, just make chutney banate, Okay. Weigh 10 grams of argentan using an electronic balance. And obviously, once you have this, then what am I going to do? I will add acid. So add excess acid to it. In this case, HCl to argentan in a beaker. You have to add it somewhere. So I place argentan in a beaker, and then I'm going to add excess acid to it. Argentan, whatever. It doesn't care. I don't care wherever I put it. You could put it in a beaker and add acid to it. Think of it. Visualize the experiment. Visualize. It's not a metal, it's an alloy. So if it's a big lump, you could powder it. Is it important to write a specific supposed mass? Yes, Ahmad Aziz. Yes, yes, yes. And then what am I going to do? What am I going to do? Then once the acid is added, keep on adding acid, keep adding acid until no more effervescence is seen. No more. This is one accuracy control. No more effervescence is observed. Then what do? I filter it out, filter the mixture. And once I filter it, obviously copper is obtained as residue. Obtained as residue. And then what do? Copper is obtained as residue. What do? I wash it with distilled water or pour this. It's better to describe things, Pour distilled water. Pour distilled water through the conical flask. The filter funnel. Where copper is. You don't need to write in order to remove traces of zinc chloride and this, but if you want, you could do it, right? And then once you got that, you're gonna dry it using a filter paper, dry it using filter paper. And one more thing, remember, whenever you're making things soluble, whenever you're adding something and you are, testing out, you're using solubility to your advantage, always remember to stir things, right? Remember to stir it. Try to heat it and stir it. Try to heat it and stir, heat and stir, heat and stir, Sir, my friends are asking that if you are Richie Rich, why do you teach chemistry? Who said I am Richie Rich, huh? Your friends have a misconception. Sir, don't lie. You have a lot of money. Stop lying. We've seen. Okay. Chill. Nazar laga lo. Hey, chill. Hello. Okay. Come back. Okay. And always, add excess acid in the beaker and stir, and stir. No, you don't need to add, you don't need a burette. Okay, wait. Some students are saying, sir, Azmir, yes, it will be uploaded onto YouTube. Some students are saying, sir, do we need to add the acid from the burette? Why? Do you want to add it like this? Tap by drop by drop, drop by drop. Come on. I'll take a acid in a measuring cylinder and I'll add it to the argentan, which is in the beaker like this. Why? I don't care. It's going to be in excess. I don't care. As the more acid I add, I don't care. I want the acid to be in excess. So it doesn't matter. Why would I use a burette? First put a filter funnel on a burette. I add the acid to it and then open the tap and slowly I'm going to, clap towards it. Wow, amazing. Oh, come on, So yes, burette is used in titration. If you're having problems with titration, watch the YouTube video, kiddo. I've done a lot of work on it. Okay. Then you're going to weigh the dried residue, residue. The third process should remain the same. So let's suppose, for example, you get 3 grams. Let's suppose you get 3 grams. So how do you calculate the percentage? Percentage is what? Mass of copper divided by total mass into 100%, So what is mass of copper? 3 grams divided by total mass, which is 10 grams into 100%. That's 30%. Khatam. Easy peasy lemon squeeze. I'm going to do all the types of questions. Chill out. For example, 3. Yeah, because I've assumed a value here, I will also assume values here. Examiner appreciates it. Yalla, please. Okay. Sir, in which reaction we use? Okay. Moving on. Muntz metal is an alloy that contains zinc and copper. I'm doing all the possible types of questions. Chill out. I'm here till 9:30. I'll solve every question. Don't worry. Okay. Sir, I swear this is awesome. Sir, you are amazing. Thanks, Dot. Thanks, guys. Thanks. Hoor, पहली दफा question 4 की समझ आई. That's awesome, Hoor. Uh, you could write formulas. You could write formula. Dilute sulfuric acid, you could write H2SO4. Doesn't make a difference. Sorry for my pathetic handwriting. I'm just grooving with. Yeah, I have a lot of work, guys. Okay. Zinc reacts with sulfuric acid. Copper does. Muntz is an alloy that contains zinc and copper. So it contains zinc and copper. I'm trying to develop, a thought process. So it's a mixture. Alloy means a mixture right here. And I'm saying it contains zinc and copper, and zinc reacts with dilute sulfuric acid. So zinc would react with sulfuric acid, and I'll keep on adding sulfuric acid until until no more effervescence is observed, right? Until no more effervescence is seen. Awesome. Then and copper wouldn't, so then I'll filter it out. I'm going to get copper as the residue and whatnot, and then I'll also wash copper with distilled water, and then I'll dry it, and then I'll also, my YouTube channel is at carboxyl. I'll wash it and I'll dry it, and then I'll weigh it on a balance, right? And initially I'll also have to weigh Muntz metal. Initially I'll also have to weigh, like, 10 grams of Muntz metal using a balance. Remember, percentage by mass. He wants me to calculate percentage by mass. Okay. Now, I'm just taking 10 grams because normally in chemistry we take smaller values, 10 grams is a good enough, it's a safe place. Your teachers should have done the practical experiments, but if they've not, you just take 10 grams. Believe me. Trust me. It's good to draw the diagrams. You'll get a mark or two from the diagram as well. If the diagrammatic knowledge is correct, you will get a mark or two from the diagram. So it's a 6-mark question. You can get 5 marks in a 6-mark question. Easily. Okay. Then so what's going to happen? So if I add acid to it, zinc is going to react. Zinc is going to, react with it. Copper will not. So zinc sulfate is soluble. It's going to, once you filter it out, you're going to get copper. Then you wash it, then you dry it, and then you're going to weigh the mass of copper. But look at the question. Plan an investigation to find the percentage by mass of zinc. Now, what am I going to do? I need zinc. I don't need what? I don't need copper. I need zinc. But it's a very easy question, because what I'll do is I'll do the same exact experiment. Let's suppose I get 3 grams of copper at the end. How do I know how much zinc was present? 10 minus 3, you got 7 grams of zinc. It's so simple, so logical, right? So total mass minus the mass of copper. So I literally just copy it from above. See? So easy. I just change the words to save time. Literally, this is your ATP. Question 4 that you guys were scared of. Hi, Suleiman Khan. Awesome. So instead of Argentan, I'll write Montes. And I do that using a Montes. What's the spelling of Montes? Montes. Yeah. Add excess HCl. No, in this case, it's what? H2SO4. I'll stir it. Keep on adding the acid until no more effervescence is observed. Filter the mixture. Copper is obtained as residue. Pour distilled water. Dry it with a filter paper. Weigh the dried residue 3 grams. But now I don't need the mass, the percentage by mass of copper. What do? I need the percentage by mass of zinc. So I'll take the total mass minus the mass of copper divided by the total mass, obviously, into 100%. So how do you do this? Total mass minus mass of copper. You could even write it in words like this, divided by total mass into 100%. So what do you get? 70%? Oh, yeah, 70. Easy. Umar Salim, I've done all the other type of questions. It's on my YouTube, Carboxyl. If you want to watch all the other type of questions, it's on YouTube. We've done it over the past couple of days. Done. I'd like to see you guys try it on your own. YouTube channel is Carboxyl, CRBOXY. I like to see you guys do this question on your own, please. Yeah, I need to show this to Sarabas. Sarabas was mocking me the other day. Sir, your money went to waste. Yes, sir. Let's go. Okay, and I like to see you try this on your own now. I've compiled all the same type of question force together. Okay, great. I will show this to Sarabas, and I'll be, Sarabas, you were making fun of me, huh? We can take a percentage of copper and subtract it from 100. Sure, Anas. You could get 30% and then subtract it from 100%. So you'll still get 70%. Sir, do we just describe the procedure and name the instrument without explaining why we do it? There's no why. No. See, that's what the examiner said in the examiner report, because I have been over the examiner reports and students don't. You need to write it in bullet points because it's much more efficient and the examiner likes it that way, right? But that doesn't mean you just say, use a burette. No, use a this, use a that. No, bullet points means write the description, but in bullet points so that it's easier for the examiner to check and grade you as well, and there'll be more clarity towards it, firstly. Secondly, the examiner has specifically said in the examiner report that students waste a lot of time telling why this is why we do this, this is why we do this, this is why we do this. He's saying, yeah, I want you guys to calculate the percentage by, let's suppose we go back to this question, right? Or maybe this question. I've asked you to calculate the percentage by mass of zinc in this case. Why are you telling me to once you filter the mixture, and you could say using the filter funnel here, using the filter funnel and the filter paper and funnel and along with filter paper. But even if I don't say it, I could just draw the diagram, whatever. But the examiner said, hey, if I'm saying pour distilled water through the filter funnel, please, he said this to students multiple times in the examiner reports, that our main objective is to get zinc, or our main objective is to find the percentage by mass. Don't go on telling me in 3 lines that the reason why I'm pouring distilled water over this is to remove traces of NaF or to remove traces of zinc sulfate from the. You're just gonna waste your time and you're just gonna take up more space. So you don't need to do this. Yeah. Don't copy things. Understand them. Done, 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 done. Okay. Did you guys do this on your own? Should we start? Ore Sajana. Yeah. Here, too easy again. Again, solubility question. Again, solubility. And I'm expecting such a question to be tested. And please remind me at the end, I will do electroplating with you. I will do extraction of aluminum from bauxite, and I'll also do extraction of iron from hematite, right? Please. I'm expecting this to come in the paper though. Chromatography you guys can do on your own. I've added a question for chromatography as well. Through the filter funnel, yes, you pour distilled water, to remove traces, because I don't care about the filtrate. A mixture contains three solid compounds: aluminum oxide, calcium carbonate, and it's solid, right? So again, solubility is going to come into play. And if solubility is going to come into play, remember, I'll heat it as well. I'll also stir it simultaneously and whatnot, to ensure that all the reactants are being mixed and whatnot. Now it says table 4.1 gives some information about these three compounds in a mixture. Again, soluble, insoluble. So I'll have to add water at some point, and then I'll also have to add sodium hydroxide at some point. It's so easy, man. Like, it's just gupshup halwa. Literally just read the question. Okay. Now, it'll be uploaded. The solved PDF will also be uploaded, Kashmala, don't worry. But try to understand the thought process, because it's not necessary that the exact same question will come in your paper, right? Okay. Plan an experiment to find the percentage by mass of calcium carbonate. So I'm interested in calcium carbonate. Again, I want to find the mass, so I'll have to take I'll have to take certain mass of this mixture. Let's suppose I take 10 grams of this mixture using a balance. Or do we need to use 10 grams of this mixture? No, we don't need to use 10 grams of this mixture, but jitna hoga. Let's suppose this mixture is 10 grams. So for example, the mixture is 10 grams. We found out that the mixture is 10 grams using an electronic balance. Done? Okay, all the question 4s are going to be done today. Ayan, come on, we're going to do everything. Question 3s and 2s, everything done as on YouTube. Ahmad, the reason why I'm doing the 6-mark questions today is because 2 and 3 are done and they're already on YouTube, guys. It's a solid. He said it's the mixture contains 3 solids. So it's a mixture, but it's just solid, right? So now what am I going to do? I need the mass. So initially I measured the mass of this mixture. It was, let's suppose, 10 grams. And then look, once I add H2O, let's think about it. Once I add H2O, this is going to become soluble. So after this becomes soluble, how do I separate this? How do I separate this calcium chloride from these insoluble substances? Again, I filter it out. So that's the first thing I'll do. First thing, I'll measure the mass, then I'll add H2O, I'll stir it, I'll heat it. Yes, we'll do all 32 pages. It'll be done till 9:30 p.m. Don't worry. Okay, so then once this becomes soluble, what is going to, insoluble just means these are going to be left as solid. So you're going to obtain these two as your residue. Aluminum oxide and calcium carbonate are going to be obtained as residue right here, Al2O3 and CaCO3. But I don't want Al2O3. So after it is obtained as residue, you add them back to a beaker. I'll add them to a beaker once again, and then I will add sodium hydroxide to it, because once I add sodium hydroxide to it, what's going to happen? The solid aluminum oxide is gonna dissolve, and you're just gonna be left with this beauty right here, because he says it reacts to form a soluble compound. So it dissolves, and then secondly, I'll filter it again. So you're gonna now get calcium carbonate as your residue. You wash it and dry it with a filter paper. Boom shaka. Wash it with distilled water and dry it with a filter paper. Yes, you can annotate on the question. Guest paper is whatever I'm doing right now. That's the guest paper. That's the predicted paper. Done. So that's the idea. And then at the end, you wash it and dry it. See, you can get 6 marks so easily. So what am I going to do? Uh, uh, determine or find the mass. Find the mass of the mixture. The mass of the mixture is, let's suppose, the mass of the mixture was found out using an electronic balance. EB, electronic balance, was 10 grams. It was 10 grams. Then what am I going to do? I'm going to add water to it. Add water, excess water. I'm going to add excess water. How do I know that the water is going to be in excess? How do I know that the water, and I'll stir it, obviously. How do I know that the water is going to be excess, Vese? How do I know? I'll know that the solid would start to decrease in size. The solid, no, there's no effervescence. Oh no, 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 oh nahi, bache. That's the thing. That's the problem. How is calcium chloride? If you add water to calcium chloride, how does it become? How do you see effervescence? Water to an ionic compound right here is just going to give you calcium chloride aqueous. There's no effervescence. There's no hydrogen, man. Kya ho gaya? Mm-mm. You can crush it if you want. You could crush it. Whatever. Doesn't make a difference. You could crush it. Crush this mixture, make it powdered or whatnot, it's up to you. But if you make it powdered, there's a chance that calcium carbonate particles become so small that they even pass through the filter paper, although it's highly unlikely, but that's why I don't want to crush it. Yeah. Okay, look at this. So how do I know that that all the calcium chloride has dissolved? Because I'll see with my naked eyes. Yeah, you could heat it as well, add water, heat and stir. But how do you know that all the calcium chloride has dissolved? It's just logical, think of visualizes. How do I know? When I'm adding it, soluble means it's going to decrease in size. So one part would decrease. Yeah, until I'm going to add water and oh, no more solid is decreasing in size. The one that was decreasing is gone, right? So that's it. That's how I figure it out. But I don't need to write that. But I'm going to stir it. Then what am I going to do? Filter the mixture. As long as you filter the mixture, then once you filter it, you obtain aluminum oxide and calcium chloride, Al2O3, and calcium carbonate is obtained as residue. Sorry for my pathetic writing, but I have to cover a lot of questions, right? So it's obtained as residue, and then again, what am I going to add now? Add sodium hydroxide, put this in, or place the residue in a beaker. But hey, I also have to wash it with distilled water. After washing them, oh, do I need to wash it with distilled water? It's not important because it's water, so it's water. But since calcium chloride was soluble, so there may be some traces of calcium chloride left. There may be some traces of calcium chloride left on top of these two. So yes, it's better to wash it with, after washing with distilled water. It's better because some calcium chloride traces may be left with distilled water. Then once I've placed them into it, then I'll add sodium hydroxide, add excess sodium hydroxide, yeah? And then I'll filter it out, filter the mixture again. So it's literally just filtration, filtration, once I add it, the aluminum oxide, you're going to write this, add this, the aluminum oxide dissolves because you're performing the experiment. You're going to write, oh, the aluminum oxide dissolves, it forms a soluble compound. You could take the wording from here. It forms a soluble compound, and calcium carbonate, there's no effect. So filter the mixture. Since calcium carbonate has no effect on is unaffected by, you could write whatever English you want, is unaffected, but the point should be the same, right? So is unaffected by NaOH, it's obtained as residue, as residue. And then again, wash it with distilled water, and dry with, by gently tapping between two filter papers, between two filter papers. Yes, I said don't need to write the reasons, but the description is there. Add NaOH, the NaAl2O3. Like you have to describe what's happening in the experiment. Okay. And then what do you do? You weigh. Did we weigh it initially? Yes. So weigh the mass of calcium carbonate using EB, electronic balance. What's, for example, 3 grams? I'm just sticking to 3 grams, whatever. So percentage is going to be calculated what? Mass of calcium carbonate, which is 3 grams divided by mass of, you could write it in English as well, divided by mass, divided by total mass into 100%. Da da da. That's what? 30%. Done, dusted, khatam. Kitna aasan? How easy? How easy? I'll go over all the type of questions. The marks wouldn't be ready. See, these are the signs that I'm saying. So if you go below these lines, these signs right here, look at this. If you go below these signs, the marks are going to be, the marks are not going to be deducted, but they're not going to be scanned. So only this part is scanned. So even if you write it here, it'll be scanned. Don't worry. Can you hear me now? Why do we need to repeat and take the average? What are we calculating? Repeat and take the average. खुदा का खौफ करें. Do you have that much time to repeat and take the average, practically speaking? Okay. Do this on your own. I'll drink water. Come on, it's pretty easy. Don't rote learn it. Don't rote learn it. Look at all the things that you have. It's not just, don't just look at one column. Look at both the columns. Hi. It says calcium carbonate, man. You guys could find this worksheet in the description of any of the latest classes that I've taken, and they are on YouTube. In their description, the link is given. The password is 1234. It's written in the link. Chalo. Guys, I have a lot of client work to do. Wrap it up tomorrow. You guys also have a paper tomorrow. I have to wrap it up. Don't write an illogical number. That's the beauty of ATP. Why do you want to write? Can you take 1 kg and put 1 kg inside a conical flask? That's why don't take an illogical number. 10 grams, 5 grams, take these numbers. 10 grams, 5 grams. And when you want to take concentration, 1 mole per decimeter cube, maybe even 2 mole per decimeter. Don't use 100 grams. You're just wasting chemicals. Yeah, I've said this. Please, Khadija, please watch the recording of question number 2s that we were doing. You could watch the graph questions. And I've stated, line of best fit can also be a curve. It depends on the trajectory of the points. What fits better? Do the curves fit or does the line fit? The class will end in an hour. Pira te fakira. Lekha te lakira. Come on, you guys can do this. Hanji. Yeah, a metal polish. A metal polish, contains these substances. A metal polish is a mixture of 4 substances. These substances. I'm just drinking water, guys. Give me a sec. Guys, you have a paper tomorrow. Come on, you guys can do this. Sir, and you are you and Sir Dynamatics brothers? Yes. Casually flexing your voice. No, I'm not flexing, yaar. Kya ho gaya? Okay, let's do this again. If you guys, what do you need? If you guys see this question, it says plan an experiment to find the mass. Mass, I'll have to take the initial mass, I'll have to measure the mass of the metal polish, take a known mass, which is maybe like 10 grams and whatnot. And um, then you do perform solubility with water, you add water, da. But realize something. You could go the longer way, which could be, first of all, you add water to it, perform filtration, and then you get these two, and then you add dilute nitric acid to it, and then you perform filtration, and then you warm it and stir it because you want to perform filtration. So you warm it and stir it, and then, you're going to perform filtration again because this will be soluble, and you're going to obtain silicon 4 oxide, then you measure the mass and whatnot. No, I'm not but all Muslims are brothers, right? But then there's also thanks, Ayan. Okay, there's also one other way. Why go the longer method? You could just add acid to it. If I add acid to it, I warm it and stir it, I acid, all of these would dissolve and I'd get no reaction here, and then boom, shakalaka. Okay. Easy. So this is easy. It's pretty easy. Do you want me to do it, or can you guys do it on your own? Just take 10 grams of metal polish using an electronic balance EB. Then what do you do? Add nitric acid excess, because I want to make sure that all of this dissolve, right? So add nitric acid excess, and then you add it in excess, and you also need to warm it, and you also need to stir it, right, in order for this to dissolve. Iron oxide, it's a solid iron oxide. So you add nitric acid, then you stir it, along with warming it using a Bunsen burner below the beaker on which the mixture is placed. See what I did there? Did you see what I did there? Did you see what I did this with my English? Because I realized that when I said add nitric acid, where would I add it? Would I add it on my head? Would I add nitric acid to my head? Would I pour it on myself? No. I'll have to add it with the metal polisher. Do I add it on the top pan balance? No, I don't. Or the electronic balance? No, I don't. So you first of all place it. So because I missed out on that, what I did was I was very, very sneaky about it. I said add nitric acid, stir it along with warming it using a Bunsen burner below the beaker on which it is placed. So I used my words and, you know, did this. So don't add it on yourself. Okay. I'm not married. Please don't. Mr. Bean's episode. Don't ask me about these things. You guys need to do questions. Amna, I think this is the one of the last questions. So you do this, you do this beauty, and then what do you do? What do we do then? You filter the mixture, filter the mixture. SiO2 is obtained as residue. And because it's not soluble in water, I'll wash it with distilled water, wash with distilled water, or pour distilled water through the filter funnel, and obviously dry it with a filter paper. And then weigh it on a top and balance. Weigh on an electronic balance. It's more accurate, Weigh it on an electronic balance. Let's suppose the mass is, for example, 3 grams. So percentage equals 3 grams over 10 grams into 100%. 30%. Done? Finished? ये वापस समझा दे. What do you mean ये वापस समझा दे? Sir, आपके clients की चिंता मुझे अंदर है. What do you want me to explain in this? It's the same thing. Literally, I've been doing the same thing for the past 10 minutes now. For the past 1 hour now, I guess. So, yeah. No. Add excess acid. Add nitric acid in excess for it to dissolve all of these three things. and this would remain, you could visualize it for us. Please visualize it. You weighed it, then you added it to a beaker, you added nitric acid to this polish, everything became soluble except for this beautiful SiO2. Then what did I do? I filtered it out. I got SiO2 as the residue. I washed it using distilled water, dried it with a filter paper, and weighed it on an electronic balance, and I got 3 grams. Literally, that's the entire idea behind the experiment. How easy is it? It's better to use a beaker. A beaker is open. How do you put all of them in a conical? It becomes difficult using a conical flask. I don't need to draw electronic. Your drawing should not be that good, but your writing should be fine. Even drawing this thing would be fine, at the end. SiO2. You don't need to draw all the steps, but SiO2, and that's the soluble solution left behind, and that's the residue. So even this much would do the job. Just mention that that's the conical flask, just a little label shable, Finished. Da, 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 da. Hey, chill out, chill out, chill out. If you do longer method, marks will be cut. No. Sir, for example, 3 gram dena zaruri. Yes. Is drawing mandatory? Try to draw it if you can. Yeah. Carboxyl, you guys can check out the YouTube carboxyl. All the other type of questions have been done there. Now, one last question for yeah, 2 last questions for solubility. Then we move on to the next type of questions. Yeah, or 3 questions. See, mostly speaking, largely speaking, solubility questions have been tested. Largely speaking, this is throughout 2023, 2024, and now it's going to be 2025. So. Yeah. 1 hour is more than enough. This is a IGCSE paper. How can you say it's not? Sir, solubility peak. Yeah. Guys, do this question. Do this question on your own and then move on to the next question. Come on, then this is salt preparation. Solubility used to prepare salt. And then we move on to the next type of questions. Yeah. You guys check this out. All these questions have something beautiful in them. Collaboration with Zanamatics when? जब बुलावा आएगा उधर से. I don't know. It's called Pira, Atif Aslam. Guys, chill out. Let's first do this paper. जब तू मेरे मौला की लेखा ते लकीरा. Okay, do this, please. Hey, M, chill out. M, chill out. I'll remove you from the class. There are 189 students, so it's difficult for me to quickly go over the messages, but I'm trying my best to go over them. Sir, please move. Move? Where move? Move? Move where? I said, where do you want me to move? Can you guys do this on your own? See, a mixture contains 3 compounds: liquid ethanol, solid sodium chloride, solid zinc carbonate. Describe how you obtain a pure sample. Now it's not a percentage by mass. The question type has changed here. But the idea is the same. The idea is the same. Ahmad, watch the recording later on then. The idea is the same. You'll use solubility to your advantage, right? So how do you get all 3 compounds? First of all, you realize that, see, how do you do this? Almost 200 students. Zainab, please, can you lower the hand? Please, Zainab, please don't. Let me just continue and finish off this class. Can I do that, please? Huh? Can I do that? Okay. Sorry, kiddo. Okay. Now, think about it. What can I do? What can I do? The initial mixture, look, the initial mixture has liquid ethanol and solid sodium chloride and solid zinc carbonate. These are both insoluble. So what should I do initially? What should I, Baloch, please, man, come on. Why do you want to come on in the video? We know you're a Baloch. We know that you're here. You showed your presence. Yeah. So what's the first thing I could do to separate them? the first thing that I could do to separate them is what? The first thing I could do to separate them is to what? First of all, just filter it out. Filter the initial mixture. If I filter the initial mixture, I'm gonna get ethanol, because it's liquid and these two are solids. So I'm just gonna get these two solids as the residue. So sodium chloride and zinc carbonate is gonna be obtained as a residue, and the filtrate is gonna be ethanol. Obviously, you guys can write the points now. I don't care. And the percentage biomass. Why would you perform titration? Golly, just filter it out. Use this solubility to your advantage. And then what do? Once you filter it out, place NaCl and zinc carbonate in a beaker, place NaCl and zinc carbonate in a beaker and add water to it. Because once you add water, sodium chloride would dissolve, zinc carbonate would remain insoluble. Remember, heat and stir. Yeah. So, and then what do? What do you do? First, you just, the first thing that I did was just filter the initial mixture because it was a liquid and two solids. How do you separate a liquid from two solids? So once you do this, NaCl would dissolve and zinc carbonate solid would be left behind. And then obviously you would filter it out, zinc carbonate would be obtained, wash it, dry it, blah. See, that's the thing. Samir, we don't need to find the percentage of zinc carbonate. We don't need to do that. So you're going to get zinc carbonate, you got ethanol, and you also need sodium chloride. So sodium chloride would be right here as the filtrate, but you don't need sodium chloride aqueous. Let's suppose we needed sodium chloride solid. So what am I going to do? Because you think pure, sodium chloride aqueous also contains water. It's not pure. So you need to remove water from it. So what do you do? What do you do? You evaporate, or sorry, you heat it till the point of crystallization. Heat till the point of crystallization for H2O to be evaporated and NaCl solid is obtained. Dry it with filter paper. Yeah. Yeah, you could say heat till dryness here, but your examiner mostly says evaporation till dryness, you could say it, and that's the better way. But normally in the marking scheme is written heat till the point of crystallization. But yeah, you guys are right. It's heating till dryness. You could just say heat the filtrate to remove water and obtain solid sodium chloride. Sir, what's your favorite house besides Godle? It's Godle. Godle. Godle cha gaya maidan mein. So I'm not going to write it. I've given you the thought process. You could write it on your own. Moving on. Next question. If they said find the percentage, what's the solution? Osama, we've done a lot of percentage questions above. Then you would have taken the initial mass, the starting mass, the ending mass. Godle cha gaya maidan mein. Okay, do this. Solid cobalt oxide, come on. Insoluble in water, but reacts with cold dilute sulfuric acid to form a solution of cobalt 2 sulfate. Remember, very slowly. So if he's reacting very slowly, what do you need to do? You need to heat it, stir it, heat it, stir it, heat it, stir it. Cobalt oxide is CO and then bigger O. Yeah, cobalt 2 oxide. Plus, what is he doing it? He's reacting it with sulfuric acid. And this is an acid-base reaction because a metal oxide is a base right here. So metal oxide plus acid, what do you get? Cobalt sulfate plus water. Cobalt sulfate plus H2O. Right? And then how to make pure dry crystals of hydrated 2 cobalt sulfate? It's excess method. You need to prepare this through excess method, The cobalt oxide should be in excess. Okay, let me draw the diagram. Let me draw the diagram. Yeah. You want me? Yes, heat, blah, blah, blah. See, the diagram would look something like this. You have a beaker. You just need pure dry crystals, hydrated. Remember, it's hydrated. It's not anhydrous. It's hydrated. You can do titration because copper oxide is a solid. It's not aqueous. You can do titration needs 2 solutions. This is what students mess up all the time. Yeah. Okay, so you have cobalt oxide, but that's going to be in excess. This is a cobalt oxide block. You can write the English for it. Yes, you should heat. Not titration. You can do titration here because there are no 2 solutions. Although acid is solid, cobalt oxide is a solid. How do you put cobalt oxide inside a burette? Think about it, Okay. So, right now, cobalt oxide is right here. And what do you do? So you're not reacting it with water, you're reacting it with acid. It reacts with acid. So what am I going to do? I'll pour excess acid. Excess acid, please don't write until effervescence, da da da. There's no effervescence, no gas is being released, right? So you take excess acid, sorry, excess acid, sorry, limiting acid. While am I saying limiting acid? Why do you need to take limiting acid? See, the concept is clear. When the concept is clear, you could immediately check out your mistake. Because the reason why it's going to be limiting acid is because once the acid reacts with cobalt oxide, all the acid would finish, and you're going to get a chunk of cobalt oxide, and you're going to get cobalt sulfate aqueous solution, right? So there's going to be a chunk of cobalt oxide left behind. And then what do I do with this chunk? I need to remove this chunk from the solution. So I'll use filtration to my advantage. Cobalt oxide would be right here, obtained as a residue, and cobalt sulfate right here, aqueous, is going to be obtained as filtrate. And remember, once you're adding the acid, you need to heat it and stir it. And stir, heat cobalt oxide or heat the acid, whatever. So take heated acid. The acid is heated first. Okay. It's not solubility, it's the preparation of salts, Ozair. And then what do you do? What do you do? Cobalt sulfate is here. You pour it into an evaporating dish because I don't need cobalt oxide. My main goal is cobalt sulfate. So how do you go from aqueous cobalt sulfate to hydrated salt? You heat it till the solution becomes saturated, And then once the solution is saturated, what do you do? What do you do, sir? You let the solution cool. Let the solution cool to form crystals. Or heat till the solution is saturated, or heat till the point of crystallization. If you write heat till dryness, it's wrong because you need a hydrated salt, not an anhydrous cobalt sulfate salt. If it was anhydrous, then you would. Why not excess acid? I've taught this, Armin, I've taught this in my live classes, but the reason why you're not using excess acid is because if the acid is in excess, then how do you separate cobalt sulfate from sulfuric acid? How do you separate the two? You can't, right? You can't. At least for O-level IGCSE, you can't. So it's much easier to separate a solid from an aqueous solution than two aqueous solutions. How do you separate the acid from the salt? That's why in excess method, why is it called excess method? Because the base or the metal carbonate is, that's in excess. Done. And then in the end, I'll just dry it. I'll just dry it by gently tapping it between two filter papers. Remember, always write description. Don't write dry it with filter paper. Dry it by gently tapping between two filter papers. Okay. Wait, guys. Wait a moment. Yeah, Khizr, I know. Can we see heat till crystallization point? Yes, Daniel. Yes, Daniel. Next question. See, I'm not doing the same type of questions. These are the questions that have been tested throughout. This is 2022. Again, what can I say? They all right. I've also added a lot of other type of questions. All the types are being covered in this paper. I'll do all the questions. Chill out. I'll do all the questions. See, I've added temperature questions. I've added all the type of questions. So don't worry about it. Just worry about solving it on time. Because we just have 1 more hour. I'll go with you guys 1 more hour, then you guys need to sleep. Come on. Be quick. Come on, Shaba. Be quick. Tamur, just take my picture. Yeah. Can we pick the pace fast? We have to cover them all. Zara, I'll make sure all are covered. You could write the English for this. Yeah, I've taught you this is how you prepare soluble salts other than group 1 or ammonium. Ammonium salts or group 1 soluble salts, they are prepared through titration because you have two solutions. Remember, whenever you have two solutions, you could use titration. Whenever you have two solutions. Yes, this will be uploaded onto YouTube, don't worry. Okay, caffeine. Let's talk about caffeine. Caffeine occurs naturally in coffee beans. First of all, we don't use such big coffee beans. We need to crush them using a pestle and a mortar, the one which we use to make chutneys, So you need to crush them using a pestle and a mortar. Now, caffeine is a white crystalline solid. It's in coffee beans. It's a white crystalline solid. Great. It's very soluble in hot water, but less soluble in cold water. What am I gonna do? I will take these big fat coffee beans. Whatever I'll do to these coffee beans, it says plan an investigation to obtain pure caffeine. I need pure caffeine. So whatever I'll do, I'll take coffee beans. I'll crush them using a pestle and a mortar. Literally, I get 2 marks for it. And then I'll not add cold water. I'll add hot water to it so that the caffeine basically it dissolves, right? And once caffeine dissolves, it's like heating till the point of crystallization or heating till the solution becomes saturated, because once the caffeine dissolves, once the caffeine dissolves, what's going to happen is you're going to let it cool. You'll use hot water, aka how do you use hot water? You add water and heat it. You add hot water, or you add water, stir it and heat it simultaneously. And then what do? You let the solution cool down, because it's not very soluble in cold water. So what you do is you let the solution cool down after filtering it, because remember, coffee beans may also have some other substances, right? Coffee beans, assume all the other substances in coffee bean are very soluble. So so what I'm going to do is I'll first take these coffee beans, I'll crush them using a pestle and a mortar. Crush them. Once I crush them, I'll add hot water to them to dissolve everything, hot water to dissolve everything. Then I'll filter. Then I'll stir it and mix as well. Stir and mix. You know. And then what am I gonna do? Once I added hot water, I will stir and mix. Add it in cold water. Yes. First, sorry, my bad, my bad. First of all, what you need to do is you first of all need to add cold water to it. Yes, my bad. So add cold water to it. That's good. So first, when you add cold water to it, the caffeine wouldn't dissolve. Caffeines would be obviously saying it is very soluble in hot, but less soluble in cold. So it wouldn't dissolve. Not all of caffeine would not dissolve in cold water, but all the other substances would dissolve. They are very soluble in both hot and cold water, right? So first you add cold water to ensure that everything else dissolves and caffeine is there. And then after cold water, you filter it out, and then you add the residue, which is effectively caffeine, into a beaker, and then you add hot water to that beaker, right? And then what do? Once you add caffeine, hot water, then no need to filter, obviously, because you now only have caffeine, you now only have hot water, and then you let the solution cool down, and obviously, crystals are going to form. That's it. Heat using Bunsen burner or water bath, it's up to you. You just need to heat it. And you could obviously let the solution cool down and dry it by gently tapping it between two fingers. And you could even wash it. In this case, you could even wash it with cold distilled water, because it's even telling you that it's not very soluble in cold water. So cold distilled water, you could even wash it. So it's pretty easy. Why heat? I'll tell you why we heat, because it's saying it's very soluble. So we also need to, yeah, you could say that, there's no point in, because you also need to, what's it called? You also need to make sure to heat it till the point of crystallization. I'll tell you, because when you add cold water to it, some may still remain, some of it may dissolve and some may still remain. So it's on you. It's on you. आपकी मर्जी है जैसे करना है. It's up to you. It's up to you. Because effectively you could obtain, it's a crystalline solid. That's why I need, probably it's like hydrated even. So I need to heat till the point of crystallization. Yeah. Done. Okay, pretty easy. It's pretty easy. Again, bismuth is a metal that has similar reactivity to that of copper. The ore bismuth contains the okay, one more thing. Sorry. What you could have done here is, okay, those of you who are getting confused, let's do something else. Let's just do this. How does this look? How does this look? Add hot water, you crush it, then you add you crush it using a pestle and a mortar. You could do multiple ways, mortar, right? And then I add hot water to it. Listen, I add hot water, just listen. I'll add hot water and some of the solid may remain. Some of, some solid particles, some solid coffee bean particles may still remain. Some of the solid coffee bean particles may still remain. Even in hot water, everything would be soluble, but some solid would still remain. So in order to, ensure that all the solids have been removed, I'd also, what's it called? I'll also remove those small coffee bean particles which may have been left behind, right? So after you filter it and you let the solution cool down, what would happen after you let the solution cool down? What would happen? Because you let the solution cool down, caffeine is not very soluble in cold water. So caffeine would start to form a solid. Caffeine would start to form a solid. Caffeine would start to form a solid. But all the other things would still be soluble. So caffeine would start to make a solid and all the other things would still be soluble. So I think this is a more logical way of going about it. You crush it using a pestle and a mortar, you immediately add hot water and stir, and to ensure that some of the solid particles, some of the solid coffee bean particles which may be left behind, to remove all of them in totality, you filter it. Here in this beaker maybe, or in this conical flask, you have everything is soluble. But remember, once you let the solution cool down, everything else would still be soluble, because everything else is soluble even in cold water. So everything else would still be soluble. The only thing which would be not be soluble, not be very soluble, would be caffeine. So it will start to precipitate. It would start to make the solid. It will start to form the solid again. Yeah. So I think this makes much more sense. You know. Give me a sec, please. Okay. That was tricky. तो आप लोगों ने मेरे पे जल्दी की हुई है. You guys have, why did we add hot water? In order to make everything soluble. Everything dissolves in hot water, everything dissolves, and when you let it cool, the caffeine precipitates and everything else is dissolved. Though I'm like 90 years old. Forget about my grades. I got A stars. This method is more accurate. I think this method is more accurate. The first method had a few errors which I saw, which I observed. Don't be blank. It's okay. You could read it. See, coffee beans, crush it with a pestle and mortar, add hot water. When you add hot water, everything dissolves, right? And then you filter it out to just ensure that some of the solid coffee beans may, if they had been left behind, they are now, they are now removed as residue, and everything else is soluble. And then when you let it cool down, the things which were soluble would still remain soluble. But because we are assuming that all the other substances are soluble in both in cold and hot substances, so everything else would still be soluble. But when you let the solution cool down, the caffeine will start to precipitate. You know. Make sense, guys? Yes, Seth. Done. Try to do this. This is also solubility question. What time will this be uploaded? Hopefully in the next 30 minutes. A pretty easy question, guys. Come on. Abdul Hadi, I think just watch the ATP classes on YouTube. Hopefully it'll help. It'll be uploaded on YouTube at Carboxyl. You know. You want to do this? So this is also solubility, and this also has to do with reactivity. So you think it's as a similar reactivity. Bismuth oxide, you could obtain bismuth from bismuth oxide through multiple methods. You could use electrolysis, you could melt it and use electrolysis. You could even react, because it has similar reactivity of copper. You could even use any metal more reactive than bismuth oxide, reacted with it and whatnot. Right? Not bismuth oxide. Yeah. And because bismite contains a compound, this is a part of an ore, right? And it says bismuth oxide is insoluble in water and it reacts with dilute acids to form an aqueous solution. The ore bismuth oxides contains no other compounds that are insoluble in water. So everything else in this ore, I'll just go over it, right? So everything else in the ore, you could use multiple methods. I'll just go over the one method that is the most easy to go about. Everything else is soluble in water. So I'll take a bismuth ore. I'll first of all crush it because it's saying it's a large lump. So if it's a large lump, I will crush it. Yes, just like you extract iron. So, it's a large lump. I'll crush it using a pestle and a mortar. I will add water to it so that everything dissolves except for bismuth oxide. Everything else would dissolve except for bismuth oxide. And then I will react it with maybe magnesium or maybe with iron. So if I react bismuth oxide with, let's suppose, magnesium, is going to react with Bi2O3, is going to give you MgO plus Bi. So I'm developing a thought process. Remember, I am developing a thought process for you guys. I am actually trying to develop a thought process rather than just teach you guys. Sir, why do we? You could use electrolysis. You could use hydrogen. You could use. It's up to you. You know. Kindly repeat this again. It's pretty easy. It's just extraction of metal. This is a bismuth ore. You need to read the question. It's saying it's insoluble in water. Everything else is bismuth oxide is insoluble, and everything else becomes soluble. See, it says no other compounds are insoluble in water, which means that the ore bismuth contains everything which is soluble except for this. So I add water, I filter it out, I get bismuth oxide, right, as my residue. And once I have this as my residue, I could react it with a more reactive metal and bismuth is gonna form. That's pretty easy. Or you could even perform electrolysis. You could add water to it, remove bismuth oxide from it. Once adding water is important to remove everything else. Adding water and filtering, add water and filter. That's important to get, you know, Bi2O3. Now it's up to you how you extract bismuth from bismuth oxide. You could extract it using displacement method of in the solid state. You could extract it using displacement in an aqueous solution. You could first react it with an acid and then probably perform displacement reaction, or maybe even you could perform electrolysis even, because you could just add water to it. Sorry, it's not going to dissolve in water. So bismuth oxide, you could melt bismuth oxide and perform electrolysis for it. Not water. If you perform that, yeah. Yes, you could first react it with an acid. You could first add water, filter, and then you could also react this with an acid, and then you're going to get bismuth. Let's suppose I use hydrochloric acid. I'm going to get bismuth chloride, and then bismuth chloride, I'd react it with magnesium. So it's up to you. You could either displace it from the salt or you could displace it in its solid state. Pretty easy. Next question. Beetroot is a colored vegetable. The color is caused by, just watch the recording again once or twice. No precautions. No, not all the other compounds would not take part in the reaction because you've removed them initially. You added water, filtered it out, all the other compounds. He's saying no other compounds are, no, in bismuth, no other compounds are insoluble in water, which means all the other compounds are soluble. He's written it indirectly. No other compounds are insoluble, which means all the others are soluble. Make sense? Yes, dissolve, not always, but in this case, yes. Done, easy. Move on to beetroot. And after this, new questions are there awaiting you. Come on, come on, come on. Can reverse titration occur? What's reverse titration? Come on, come on, come on. You add just magnesium metal, Iman. Do this. Yes, it's a pretty easy experiment. Do you want me to go over it? It's pretty easy. It says beetroot is a colored vegetable. So it's a vegetable. First of all, you take this colored vegetable, you crush it with the help of a pestle and a mortar. You crush it with the help of a pestle and a mortar. Yeah, makes sense. And then once you've crushed it with the help of pestle and a mortar, it says the color is caused by a mixture of water-soluble compounds. So you know that it's going to dissolve in water. So what am I going to do? What am I going to do? I will obviously add water to it. And once I've added water to it, I will perform chromatography. And then at the bottom, as my solvent, I'll use water. I'll dip the paper in water, and then the water is going to rise up the chromatography paper, and then all the different spots are going to be the number of colored substances that you have are going to be identified through the number of spots. So the number of spots that I get are going to be actually the number of colored substances that I'm going to have. Why do we dissolve it in water? Because it's saying the color is caused by a mixture of water soluble colored compounds. I can't place. What do you place on a chromatography paper? What do you place on a chromatography paper? What do you place on a chromatography paper? Do you place a solid, or do you place a solution, a liquid, an analyte? So the analyte must be a liquid, right? It must be a solution. So that's why I added water to it even. And then I placed the drop. And then the water, I'll use water as my solvent even, and it'll rise up the paper. How do I decide? Because I know that the substance, it would be soluble in water. So I can use my solvent. The solvent that you use is always going to be a solvent in which the analyte is soluble. Baseline with a pencil, blue, blah, blah. You could write all of that stuff. Okay, done. Moving on to the next question. Now, aqueous solutions. Just by even looking at aqueous solutions, what do I get? Just by even looking at aqueous solutions, what comes to my mind? What we do if it is not soluble in water? Then you use another solvent. Yeah, come on. Yeah, I'm trying to kick out this one student. He's not a student probably. I'm gonna close the meeting because I'll enable waiting room, because that's the only way. Because of this student, I can't see the questions. Yes, so when there are two solutions involved, that's basically you'll perform titration analysis. Greaseway and Kitchen Clean are two soluble solutions used as household cleaners that contains aqueous ammonia. It says plan an investigation to find out in which has the highest concentration. So what am I going to do? Which one has the highest concentration, everybody? Yes, you can absolutely do titration. Which one? Remember, we've done this in titration. Remember? Do you want me to remind it? Do you want me to remind it? If you've done the question number 2, it's pretty easy. I'm just going to give you the thought process. You guys can do it on your own, you know. So you'll use an indicator and whatnot, blah, blah, blah. But here I'm going to add the acid. The acid is going to have the same concentration. Let's suppose I'm going to add like 1 mole per dm cube of sulfuric acid and whatnot, And then in this case, in the conical flask, I pipetted out 25 cm cube of A, which I'll call the greaseway one. And the kitchen clean is going to be, let's suppose, 25 cm cube of kitchen clean, right? That's greasy. And then let's suppose in one case, 20 cm cube of acid was used, and in the other case, 30 cm cube of acid was used. Which one is more concentrated? Which one required more acid? The sample that required more acid. Yes, B, this K right here, K is more concentrated. The one that, why is 20 cm cube more concentrated? Ahmed, come on. The acid was the same concentration, and G required 20 of it, the same amount. For K required more of it. So this required more of acid to be neutralized. Yes, we want ammonia concentration, right? So ammonia is the household cleaners contain aqueous ammonia. It's basically aqueous ammonia, right? Make sense? Can you put aqueous ammonia in a conical flask and view so that can you put aqueous ammonia as it can evaporate? So it should be burette. It doesn't matter. It's both is the same thing. It doesn't matter, to be honest. Here. So that's the entire experiment. You know how to perform titration. You know how to perform. Asad, you can watch the recording on YouTube. Write this, sir, for titration. What is titration? Yeah, you just need to take a known concentration of acid. Let's suppose I took hydrochloric acid of 1 mole per dm cube, added to the burette. I added this to the burette. Then in the conical flask, I added aqueous ammonia. Aqueous ammonia. I'm saying I added G and K to two different conical flasks. Or you could perform it for G and then repeat it for K. So add G to conical flask. Kitna G? 25 cm cube of G using a pipette along with a pipette filler, blah, blah. Add methyl orange. The color is obviously gonna be like yellow. and then you start the burette, add acid from burette, swirl the flask. You've done all of the experiments. Swirl, SWIRL, swirl the flask, you know, and then when the end point is when the indicator changes color, indicator changes color, you stop the experiment, record the volume of neutralization. Let's suppose for G it required 20 cm cube, and then uh, repeat the experiment with K, and then for example K had uh, 30 cm cube, K needed 30 cm cube of acid. So since K required a larger volume of acid, it is more concentrated. Done. Oh, I'm trying to kick out this one student, yeah. I'm gonna close the meeting, I'm sorry. What? It's not a student, probably some troll. Because he's spamming messages. How do I just remove it? Oh, he's so smart. The student's so smart. I think they changed the name. The problem is that if I stop the meeting, then can I block his messaging access? How? I don't know. Whatever troll this is, man, let the student study. Come on. I've kicked him out multiple times, but unfortunately, they join in again and again. What can I say? I don't know, some trollers. So that's how you go about the experiment. How easy is it? It's simple. Again, can I perform the same experiment for this juice? I've banned it, but it's still coming inside because it's an open meeting. Okay. Still, can I do the same experiment for the citric juice? The concentration, see, your two solutions. Citric acid, you have acid and alkali. Acid and alkali, what should click in your brain? Titration. What should click in your brain? Titration. Exactly the same. Exactly the same. You want to figure out which of these two solutions is more, which of these two solution is has the more concentrated aqueous citric acid, right? So I'll pour the citric acid in the conical flask, and obviously the sodium hydroxide is going to be in the burette. And same, you have to have burette, pipette, citric lemon juice here. Where is it? What do we need to do? Pipette out 25 cm cube of lime juice here and 25 cm cube of lemon juice here. And the one which requires more volume of neutralization of sodium hydroxide, that one is, yes, indicator, blue, blah, blah. Don't use methyl red, use methyl orange. And here you could say when the indicator changes color from yellow to red, and in this case it'll go from indicator, but because the conical flask contained the acid, so it'll go from red to yellow. You could also write orange, it's fine. Done, finished. Last experiments. These are literally the only type of experiments which have been tested. Yes, chromatography experiment can come now. It has come. How easy was it? Everywhere we were using solubilities. One is temperature change. One reaction is for temperature change. I'll do this. You could say red to yellow or red to orange. It's up to you. But it's better to write yellow because in alkali it's yellow. I've said this before. Yes, M.INA. No, hydrolysis is not going to come. Hydrolysis is good. Aina, it's yellow to orange. No, it's better to say yellow to red. बेटा मैं भी मार्किंग स्कीम बैठा हुआ हूँ ना आपके साथ. We've performed this practically when we were in A levels. We know things. So it can be, don't just, and you'll see marking schemes at one point it'll be yellow to orange and at one point it'll be yellow to red. So you're just going to get confused. So it's better to just know the colors. Yeah. These are the expected questions. Other than this, it's difficult. Electroplating can come. Maybe, probably. Electroplating shayad aa jaye. May come, but I don't think so. May come in question form. Electroplating pretty easy, right? February March में आई थी फिर I highly doubt it's gonna come, but electroplating though. And even extraction of aluminum and extraction of iron. Please do extraction of aluminum. I'm just doing this one experiment because after this one, all the other four are literally just copy paste. Or the all the other five, all the other six are effectively just copy paste. I was just giving you guys multiple thought process. You just need to read the question carefully. Yeah. Can you do it in detail? M.ina, I'm doing it in detail. क्या हो गया? You can write the English for it even, but it's pretty easy. Okay. The class is till 9:30. I'll go till 9:30 with you all, huh? No, I did my A levels from Hson College, Lahore, not LGS, Ahmad. Fractional distillation के methods कौन से होते हैं आयशा? Shabayan, let's go. As in godly. I'm tired, guys. To be honest, I just want to do this one question and then I'll go over the. Inshallah, Samir will be easy. Don't worry about it. I'll do this one question and I'll go over the temperature change questions. Yahoo. Help, why are you seeing me since the start of the class? Sorry, kiddo, what messages have you sent? Maheen, you could send the message, you know? Yes, the acid can be in the flask, but then your conclusion would be a little different. You could see titration videos for it. Okay. Copper to carbonate reacts with sulfuric acid. Remember, when a gas is being formed, remember that experiment. Remember this experiment. Remember? A bung is here and the gas syringe is here, and you could literally use this experiment throughout for any type of rate of reaction question. If you want to find out the temperature, if you want to find out concentration, just manipulate it and cater it to this reaction, right? So how do you plan an experiment to determine the volume of carbon dioxide form? So you could even determine the volume of carbon dioxide form. You start the experiment, you add these two, known mass this, known mass that, known concentration, blah 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 blah. You measure it. You measure, like I'll take 5 grams of copper carbonate, add it to sulfuric acid in a conical flask. I'll add bung to it to prevent the carbon dioxide from escaping. And once the reaction starts to take place, I'm gonna obtain carbon dioxide in my gas syringe, right? So that's one way. And then to improve accuracy, you could repeat the experiment and you could take the average for it. Zoya Singh, please write this one. Okay, Zoya, I'll do it for you. So what do? You need to see the equation. How do you think about it? How do you think about it? The equation is literally what you need to do. So what do you need to do? I'll take 5 grams of copper carbonate, and how do I know? I'll wait using I'll use, you see, how does carbon dioxide form? Think about it like this. How does carbon dioxide form? How does carbon dioxide form? How does carbon dioxide form? When these two react. And so you have to react this with this, and then you have to measure this and this, right? So I'll take 5 grams of copper carbonate and using, how do you know it's 5 grams? Using an electronic balance. Weigh 5 grams of copper carbonate using an electronic balance, right? And then what am I going to do? I'm going to add acid to it. So add 1 mole per dm cube of, let's suppose in this case I'm using sulfuric acid, right? So I'll add 1 mole per dm cube of sulfuric acid to 5 grams of copper carbonate in a conical flask. And remember, the sulfuric acid that I will be adding is going to be in excess. Why? Because the examiner says, tell me how much volume of carbon dioxide will be formed when a known mass of copper carbonate completely reacts with dilute sulfuric acid. How do you know that all of the copper carbonate would react with dilute sulfuric acid? How do we know that all of the copper carbonate would react with dilute sulfuric acid? When the dilute sulfuric acid is in excess, obviously. When the dilute sulfuric acid is in excess, and how would you know that dilute sulfuric acid is in excess? How would you know? Because the bubbles will stop to form, right? And then you need to also draw this beautiful diagram. It's very beautiful, it's very easy. And then insert a bung, attach it, attached insert a bung to prevent CO2 from escaping, right? And then what do I do? Obviously, the experiment looks more like this, This is how it looks. The apparatus looks more like this. Sorry for my pathetic drawing, but that's the bung. You could even, show this diagram, and that's the conical flask, and that's the gas syringe. So then what do? You connect, or not just connect, you could say, record the volume of carbon dioxide. Carbon dioxide would start to be, collected. This is called a delivery tube. Yes. So carbon dioxide, record the volume of carbon dioxide collected in the gas syringe, collected in a gas syringe. Yes, Talha, you could do that. In a gas syringe via a delivery tube. Yeah. And carbon dioxide will be collected. And that's it. Literally, that's it. Now, also realize that this will literally give me 6 marks. Don't worry about it. This would give me 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for inserting a bung, 1 mark for this, 1 mark for this. Now, certain precautions. See, he's saying, how do you ensure that the volume is as accurate as possible? So for accuracy, you could even repeat the experiment and take average, and take average. And one more thing that you could do is use a glass divider. What's a glass divider? Some of you guys may wonder, sir, if you remove the bung and then you add the acid to it, it's possible that carbon dioxide may escape during this process, right? Carbon dioxide, you could call it a stopper as well. It's called a bung or a stopper. It's possible that when you take this off and you add the acid to it, the carbon dioxide may escape, So the solution for that is to use a glass divider. So there's a glass right here, you pour the acid right here, and you place the solid particles right here, and the glass divider right here is attached with a thread. It's attached with a thread. So once you pull this thread, the glass divider flips, it becomes horizontal, and the acid is allowed to mix with this. So you could use a partition container, you could use a glass divider, you could use whatever, but just make sure that they don't come into contact initially. You put the acid here, you put this here, and then you just pull this to make it horizontal, and then they start reacting. So that's one precaution as well, one accuracy statement. And also further, how do you know that the acid is in excess? You're gonna wait until no more bubbles are seen, That's how we know that all the calcium carbonate have reacted. So that's the thought process. I'm always giving you thought processes. Moles and stoichiometry to experiment आपने क्या moles and stoichiometry is just a derivation from this experiment. I'll upload it, don't worry. How do we make calcium carbonate in excess rather than the acid? We don't need calcium carbonate in excess. We need calcium carbonate in limiting as a limiting reactant, because he's saying I need all of this. I need all of the copper carbonate reactant. It's not calcium, it's copper. Won't the gloss be involved in the reaction? No, you just quickly pull it. It won't. You just quickly pull it. You pull it enough in the air so that it goes like a little up. Yeah, I'm getting tired. Yes, you're right. Organic chem, I don't know. Maybe. But whatever is tested, he'll give you all the information. So similarly, now check this out. This was how you collected this gas. And now check this out. Plan an investigation to find out which one contains the highest concentration. So how do you perform a concentration experiment? Literally, I will perform the same experiment, but what I'll do is I'll use a timer. And then I'll wait and I'll see, okay, in the first 30 seconds, which one has the most carbon dioxide being glass divider. You could use it as a precaution, ताकि अगर आप इसमें if you guys add acid directly to it, there's a possibility that the reaction becomes so quick that when you added you were not quick enough to add the bung, and some of the carbon dioxide may escape. That's why you put this divider and you insert the bung, so that when this reaction starts to take place, the conical flask is sealed. Now you're going to perform the same experiment. Which of these two has the highest concentration? Phosphoric acid reacts with sodium carbonate. You could use the same experiment, please. You could use the same experiment, and then the one that would give you, because this is the acid and sodium hydrogen carbonate was going to give you carbon dioxide, right? So this is and see, he's telling you that it gives you carbon dioxide. You could read the question again on your own, but you could use the same experiment, just time it and just wait. Okay, in the first 30 seconds, the first acid gave me, in the first 30-second value, cola gave me 20 cm cube of acid, and Coca-Cola gave me 40 cm cube of acid. So what do I use? Yeah. Sodium hydrogen carbonate is baking soda. It's a solid. It's baking soda. Yeah. So you do the entire experiment. You do the entire experiment with the same ideology. Remember, highest concentration, temperature, catalyst, whatever you want to do. And I have compiled all of this. You do the same experiment, just make sure to use a stopwatch, and the one that I'll have, for a certain time. Let's suppose in the first 30 seconds, value cola gave you 20 cm cube and the Coca-Cola gave you 40 cm cube of carbon dioxide, which means Coca-Cola has the fastest rate of reaction. Or you could measure the volume of gas being produced as equal time intervals, and then you could plot a graph and find the gradient of that graph. That's also correct. It's up to you. Yeah, I've written this down. It's the same thing, literally. You just need to react the two. You just need to react the two. Literally the same experiment. React the two. Carbon dioxide will be collected, and you will get it. The one that'll have carbon dioxide, the one that'll get the volume of carbon dioxide quickly. In the first 30 seconds. Let's suppose the first one gave you 20 cm cube and the second one gave you 30 cm cube. It's better to use this experiment. Now I'm giving you a quick idea. And similarly, for the third question, same thing. See, zinc reacts, a gas is being formed. A gas is being formed directly. This should come to your brain. Gas is being formed. And how do you know? You know this, you know how to carry this experiment by literally looking at what is being reacted. So you need to react these two together. Take 5 grams of this weight using a balance, add a sulfuric acid, make sure it's in excess. How do you know it's in excess? No more no more effervescence is seen, blue, blah, blah, da, 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 and whatnot. You know, literally. And he's saying, show that copper is a catalyst for this reaction. So you do perform this reaction all over again, but instead you add copper to it. And when you add copper to it, you'll realize that the time it took for hydrogen gas, for 20 cm cube of hydrogen gas, in the first experiment, it maybe was 10 seconds. In the second experiment, maybe it's like 20. In the first, if it took 10 seconds to get 20 cm cubes, maybe in the second experiment, in which you used a catalyst, maybe it took 10 cm, it gave you 20 cm cube in 5 seconds, So it's up to you. Again, next question. Next question. How do you measure that? You have this experiment. I'm saying everything is connected to this experiment. Literally, you could draw it. Yes, you could draw it. Yes, it's better to draw it even. So I'm just using the same idea, the same experiment. Whenever he's asking me about concentration, temperature, surface area, I will use the same experiment. I'll perform everything, and then I'll keep everything constant, except if he wants the effect of catalyst, I'll add a catalyst here. If he wants the effect of temperature in the second experiment, I'll make sure that the reactant that I'm adding is a little heated. How do we put it into words? You put it into words by writing all of this. And then you just switch it, And I think I've even uploaded an experiment for this. So this reaction is very, very, very crucial. Your teachers should have done this with you. And it's going to be used everywhere. See, a catalyst, so you perform the second experiment, but with a catalyst. And you'll notice that it'll take less time to get 20 cm cube with a catalyst and more time uh, without a catalyst, right? Or maybe you could even say that in the first 10 seconds, you got 20 cm cube, for the uncatalyzed reaction, and in the first 10 seconds you got 30 cm cube. So that's up to your conclusion how you want to look at it. Or you could measure the volume of gas being produced at equal time intervals, plot a graph, find the gradient, and the one that will have the higher concentration would have a higher gradient. So it's up to you how you view it. Similarly, this right here, calcium, cobalt, and vanadium, they're all metals. How do you find out their reactivity? It should be a fair test. Again, I will do the exact same experiment right here because they are metals. And metals, when I react them with acids, they're going to give me a gas. And if a gas is being produced, the exact same experiment will be carried out by me. The more reactive, I'll wait and I'll see, okay, in 10 seconds, how much volume of hydrogen was being produced for zinc, how much volume of hydrogen was being produced for cobalt, how much volume of hydrogen was being produced for the other one. And you'll notice that the one that has the highest rate of reaction for 10 seconds, it would get the highest volume of a gas for the same amount of time, right? So again, the same thing. How do you get the reactivity? You literally just react them. Where is it? You literally react them and collect the gas. Rate of reaction. Again, next question. That's why I used this. Same. How do you find the temperature of the aqueous hydrogen? How do you know that, plan an investigation to find how the temperature of aqueous hydrogen peroxide affects the rate of catalyzed reaction. So in both cases you have a catalyst, because you're saying it's very slow until you add a catalyst. So in both cases you have a catalyst, but you need to, in one case, because oxygen is being formed, I could use the same experiment. And in one case, what I'll do is I will make sure that hydrogen peroxide is heated in one case. And I'll see that the one in which it is heated, it will give me, for the same amount of time, it'll give me more volume of oxygen compared to the one that is that has a lower temperature. Done. So always use a gas syringe. Pretty easy. Pretty easy. See, easy peasy lemon squeezy. Again, same. Again, same. Gas syringe, blue blah blah, blue blah blah. It's all the same. It's all the same. It's all the same. Iron rusts. Now, this is a different type of question which I've added. But before I do this, I'm gonna do before I do this, I want to do the energy questions. They're all the same. Abiha, you could even do it on your own. They're all the same. Just keep in mind, even if it is not written in the markings, you just keep in mind the logical idea behind it. So concentration, temperature, do da 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 da, collection of gas. Remember the gas syringe and remember this is the best advice. If there are two aqueous solution, perform titration. If there are, if you want to collect a gas, if you want to find the rate of reaction, do what? What do you do? You literally use the gas syringe, and this, in one case you heat it, in the other case, if you want to take surface area, you use powdered particles, and in the second, when you repeat the experiment the second time and whatnot, it's pretty easy. Yeah. Now, energy change. This is a very beautiful question. Naini, who said upward downward displacement is removed? Okay, do this question, please. Do this question. Alice. Can I guys do the temperature question? I'm getting so tired. Why do you need a tracing paper? Can you guys read it and try to do it on your own? Just one more question. One this question, and then one this question, because these were questions that were tested and these are beautiful questions. So one, and one. Sir, Assalamu alaikum. Shaz here, your Purana student. Just wanted to say hi, I miss you so much. A-level chemistry P2 on Monday. Please pray. Also, thank you so much for helping us. Thank you, Shaz. Thank you, man. I miss you too. Keep on spreading the word of knowledge and best of luck for your paper, kiddo. Best of luck. Hopefully, you ace it. I'm proud of you. Okay, just do one temperature change question, because this is like I wouldn't call it like a calorimetry question, because it's so pathetically, this experiment is so pathetically designed, but hey. I'll upload this inshallah in 30 minutes. I'm just doing one more question, this temperature question. Test tubes are pretty small, boiling tube, test tubes. Conical flasks are huge compared to a test tube, obviously. If they're saying upward and downward is removed, then it's if they're saying it, then it's fine. मैं क्या कर सकते- Can you guys solve this, please? Can you guys solve this, please? Read the question. Read the question. She says, the energy given out when different liquid alcohols are burnt can be compared using the apparatus. Okay. Describe how the apparatus shown can be used to compare the amount of energy given out by three different alcohols. Your answer should include how the results can be determined which fuel gives the most energy. It's pretty easy. Let's suppose I want to figure out, let's suppose I want to figure out, mm, how do you do this? You do this through multiple ways, you do this through multiple ways. What I'll do is I'll say, yeah, I'm gonna heat this water to, let's suppose, 50 degrees Celsius. This is my way of doing it. You could do any way, but let's suppose I want to heat this water that it contains to 50 degrees Celsius. I'll use ethanol first, then I'll use propanol, and then I'll use butanol, and I'll have a timer in my hand. I'll have a timer. I'll start the digital stop clock, and then I'll start to heat this up, and I'll start the digital stop clock. Let's suppose for ethanol it took 10 sec for ethanol, let's suppose it took 1 minute. For propanol it took 1.5 minute, let's suppose, and for butanol, let's suppose it took 2 minutes, right? So it's pretty easy. How do you know? How do you know which one will give out the highest amount of energy? The one used to compare the amount of energy given out, right? So the one that is heating it the quickest is the one that is giving the highest energy being given out. And yes, heat would be lost, da 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 da. That's why I said it's a very pathetically designed, but that's not our idea. And you would have also said you heat it, and you will record the highest temperature. This is one way of going about it. You could go about it like this: oh, heat it, and you heat it for, let's suppose, 2 minutes. I will heat this for, let's suppose, 2 minutes, and I'll see the highest temperature reached in 2 minutes. So one is reaching 50, one is reaching 60, one is reaching 70, let's suppose, right? So the one that reached 70, the highest temperature, uh, that is in the shortest, the one that reached this highest temperature in the same amount of time would have the highest, would give out the highest energy, right? But okay, I'll write it for you. If you want, I'll write it for you. But the things that you need to keep constant is the volume of water, which should be the same, the temperature of water should be the same, the mass of alcohol that you are adding should be the same. So the 3 marks were for literally putting these precautions. So make sure that the mass of water is same, initial mass slash volume, mass slash volume of water is same. You would say the initial temperature of water is same. These are the precautions, because most of the marks were for these. And then like, you'll also make sure that liquid, because you need to keep things constant, right? So yeah, yeah. Liquid alcohol, yeah. The heat water using spirit burner, yeah, that should also be, you need to heat it, yeah. That should also be the same. Can we burn for a set time and then calculate difference in the temperature? Yeah, you could burn for a set time and don't need to calculate difference in the temperatures. If you burn for a set time, I said, if I want to burn for 2 minutes, one give me 50, one give me 70, one give me 60. So the one that gave me the highest energy was basically the one that gave out the most energy. And then what do? I'm going to start the timer as I heat. I'm going to start the timer as I heat. And then what I'm going to do, I'll heat it. Let's suppose I want to heat it till 50. So I'll heat it to 50 degrees Celsius. The one that took the least time, took the least time means that it gave out the highest slash most energy. Done, khatam, finished. Shortest time or least time. Literally 6 marks are for this. खत्म यार मैं थक गया हूँ to be honest. See Endo, exo, you guys can do this on your own. Endo, exo. You could search for the marking scheme if you want. It's pretty easy. That's pretty much it, you know. I'm just getting tired, very tired. Colored substances can be used using pH indicator. These colors are soluble in ethanol, but again, solubility type of question. And then pH, so remember you need to add indicators. You know, my energy has gone so low, so low. I'm feeling drowsy now. So this is it, guys. I think, you know, um I need to stay up and do. I'll post it. I'll post it. I'll post the PDF onto YouTube. Rusting. What about rusting, Mas? There's nothing wrong in rusting. Don't be scared. Rusting is just when iron comes into contact with oxygen and with water. Electroplating and bauxite. Just explain electroplating and bauxite. Electroplating is pretty simple, you know. If you wanna electroplate something, you know, the object that you want to electroplate, that should be at the cathode, or that should effectively be your cathode. Let's suppose um I wanna electroplate a heart iPhone, right? Or a heart phone. So at the positive terminal, I'll attach the metal. The so at the anode, the anode should be what? The anode should be the metal which you want to electroplate the object with. Electroplate the object with, right? The cathode should be the object, right? Cathode is the negative electrode, right? Should be the object. And then electrolyte. What should be the electrolyte? Remember, let's suppose I wanna, you know, I wanna electroplate it with copper. So I'll use copper electrode right here, positive electrode, and I'll use copper nitrate. So the electrolyte should be like, you know, or copper sulfate, whatever, aqueous, right? So electrolyte should be a soluble salt of the metal, or a soluble compound of the metal. I want to electroplate with copper, so I'll use a soluble compound of the metal. So I'll use a soluble compound of the metal that I want to electroplate the object with. And what's actually going to happen is the copper to, why are we doing this? Why should this be at the cathode and not at the anode? Because it'll have a negative charge all over it. It'll attract the positive ions. So copper 2 plus ions will gain 2 electrons and become copper. A pink solid is going to be deposited right here on the surface of the metal, right? And to compensate for these copper 2 plus ions, the anode is going to dissolve. Anode dissolves to give you more copper 2 plus ions, to give more copper 2 plus ions, and that is the reason why you need to replace the anode regularly. Replace the anode regularly. So if this were to come, you could easily, you know, cater to it. If you want me to talk about the extraction of aluminum from bauxite, yeah, writing the equations is good, you know, it's good. It just adds to it. It's a 6 mark question. It's better if you add things to it. And if you want me to explain electrolysis of aluminum oxide, you're just gonna melt it, but before you melt it, add molten cryolite to it. Molten cryolite, you know, to air to bauxite. Why do you need to add molten cryolite to bauxite? Why? In order to improve conductivity and to lower the melting point, right? And then what do? You melt Al2O3, melt Al2O3. The electrodes should be of graphite, you know, graphite electrodes, because they're good conductors. And then once you melt it, the aluminum 3 plus ions are going to go towards the cathode, the O2 minus ions are going to go towards the anode, and you could even write the equation for it. This would happen, you know, a silvery gray solid would be deposited at the cathode, which is the negative electrode, and O2 minus is gonna go together to give you oxygen by losing 2 electrons in total. Each would lose 2 electrons, so by losing 4 electrons in total, and this oxygen would react with the graphite electrodes, which are obviously carbon electrodes, and it's gonna give you carbon dioxide. That's why the anode needs to be replaced. Khatam, guys, done. Finished. 3 methods of rusting. What are the methods for rusting? Rusting takes place when iron comes into contact with oxygen and water. What are the methods? Thank you, guys. Hematite kabhi bata do. I'm just getting drowsy now, guys. When I tell you hematite, dekho, what do? You have a blast furnace, you know, As look some things, you could search how it looks. I always, I look something like this. I always mess up making it. But you're gonna pump in hot air at the bottom, not oxygen, hot air, right? Because we don't separate oxygen from the air. Although we know that when you add hematite here, I'm gonna add hematite, I'm gonna add coke, and I'm gonna add limestone. And you're gonna write this limestone is calcium carbonate, right? So pump in hot air at the bottom, and then what you need to do is once you add this, second thing is add all of the above to the blast furnace, all of the above to the blast furnace. Or you could swap their places. First write this and then write this. And then what's gonna happen? I'm just gonna write the equations and say the English, and you could write the English. Then what happens is that the coke reacts with oxygen to give you carbon dioxide, which is a highly exothermic reaction. The carbon dioxide is reduced by coke to give you carbon monoxide, sir. And once you get carbon monoxide, it reacts with Fe2O3 to give you iron and carbon dioxide, and iron is therefore extracted, obviously. But you need to understand that the reason why you added limestone was because the calcium carbonate, because of this highly exothermic reaction, the calcium carbonate would decompose to give you calcium oxide and carbon dioxide. This calcium oxide would react with silicon oxide to give you calcium silicate, which is slag, and this is less dense than iron, therefore it will be at the bottom, therefore it will be at the top, and iron will be at the bottom. And iron is extracted from by opening the bottom tab. So iron is, and you could write that English. So iron is extracted from the bottom tab, or removed, or collected. It's better to write collected from bottom tab. And what are my waste gases? Because you pumped in hot air, the only particle or component that reacted from hot air was oxygen. So nitrogen, and it's nitrogen and argon and carbon dioxide. These are the waste gases which you use backward. The waste gases come out from the top, and you pump them back to heat up that air. Pump them back. So that's that, guys. Yeah. One joke, sure. Guys, this is all you need to know. To be honest, if you know all of this and if you've understood all of this, hopefully all of this. Sir, does iron extraction come though? It hasn't come, but it can come. Thank you, guys. Thank you so much. I love you all. I hope it helped. I hope this class helped. Yeah, I have a lot of work to do now. I can't sleep. So I'm gonna go and work. But thank you so much for being here. I wish you all the best of luck, and hopefully I'll get, yes, we'll do 1,000 MCQ marathon, hopefully, but hopefully your papers you get good marks in your exams. And I also pray that, you know, I get messages of happiness from you guys that, sir, whatever we did, all of that came and whatnot. So thank you, everybody. Thank you for all your wholesome messages. I'll upload this video right away. Thank you, guys. Bye bye. Ciao. I'm a little drowsy now, but bye bye. Ciao.